Okay, that was possibly the best dinner I've ever eaten in my whole life. And you're in the welcome back to Tehachapi, California, in the storage room. And so where a new video setup has been taking place. I have to show it to you. It's so beautiful. Right here, see, I have a camera hanging, and I have this black box, and I have this wood, and then I have my see, this is all created out of stuff just right out of the backyard. To hang that up there. Okay, so here we go. It's beautiful. Pay-per-view. So I don't think I said, but this is more examples on 2.3. So, and this is problem 75. Again, I always try to do the ones that are, kind of like doing your homework here. So it's asking me, biologists have proposed a cubic polynomial to model the length of an Alaskan rockfish at age A. And there they give it, where L is measured in inches and A in years. Calculate DL/DA when A is 12 and interpret your results. Interpret your answer. Okay, so they want me to find DL/DA, so that's not hard. DL/DA, and I notice that this thing is all just power rule, right? And so in 2.3, I was learning about the shortcut rules. So I don't have to find the limit using the long rules. I can use the shortcut rule. The power rule says take the exponent and multiply it by the coefficient down in front right there. And so in this case, I'm going to be, can you see my calculator screen? I'm going to be multiplying 0.0155 times 3. And of course, this calculator wants to give me everything as a fraction because that's the standard way that things are put. But I'm going to want it as a decimal. And so this is going to be equal 0.0465 a raised to the, and then you remember what you do, you take 1 away from the exponent. So on my exponent, this exponent is 3. I take away 1, I get 2 for the new exponent. And then minus, and then I take the 2 that's right there. This is the power rule for finding the shortcut of the derivative, and I multiply it by the 3.372, and it's negative. So I'm not going to put the negative in my calculator, but 0.372 times 2, and I got 93 over 125. And of course, my lighting's not just perfect in my new little setup, even though I was bragging about it, but maybe it's a little better when I moved it. 0.744. I already have the negative there. Make sure that looks like a 0. A to the, and then the exponent is 2, take away 1 is 1. And you don't have to write A to the 1, it's just A, so we're good there. And then here, you get used to it, but when you take the derivative of 3.95a, it's just 3.95. But if you're wondering why, there's a 1 right there, and the 1 comes in, oh, come on, you're okay. Yeah, she comes in crying. Do you want to get up and see all the friends? You want the friends to see you? Here, we'll go pay-per-view, and you can see all the friends. This is who's been crying at the door. I don't know if you guys could see her, but she was so upset about being locked out. And okay, so the 1 multiplies by the 3.95, so we get plus 3.95. And then it would be the exponent, so I have my exponents going up here, would be 1 take away 1, which is 0. So that would be a to the 0. And a to the 0 is equal to 1. So if you're wondering why it's just 3.95, you do get used to it, and you don't go through all that. You just say, and then the derivative of a constant is 0. So here I've taken the derivative, and they wanted me to evaluate that when a is equal to 12. So now I'm going to put right in here equals, so this is my derivative, 0.0465 and 12 squared minus 0.744a, which is 12, plus 3.95, and I'm going to put that in my calculator. So 0.0465 times 12 squared, and so then minus 0.744 times 12 plus 3.95. Probably give it to me as a fraction again, but I'm going to push S to D. 1.718. Now they wanted me to interpret this answer, and it really helps just to have the units on it and then on interpreting it. So remember what they said L was in. L was in inches, and A was in years. And so this is inches per year. And this was talking about the length of Alaskan rockfish at age A. And so this tells us that it's growing, getting a little bit bigger at 1.718 inches per year when the rockfish is 12 years old. So at 12 years old, this fish is increasing in length by this amount. So at 12 years old, the rockfish is growing in length about 1.7 inches per year. Something like that. I don't know. To kind of give an idea that I just kind of know what's kind of going on a little bit with it. Okay, so then 88 says, for what value of x does the graph f of x equals that have a horizontal tangent? So we talked about this in class, I'm sure. Horizontal tangent means that, so you have your curve coming along and it has a horizontal tangent, right? And so what that means is the slope of the tangent line is equal to 0. And so I hope that's what you're thinking there. And so what I need to do is I need to find the derivative and set it equal to 0 and then find what points go with that. So and I don't have to use the definition of the derivative. I'm okay to use the shortcut rules. So f prime, so I'm taking the derivative of f, which is f prime at x, equals the 3 comes down in front, 3x squared. The 2 comes down in front and multiplies with the 3, 6x to the first, right? And then this is 1, right? You can think about that with the exponent of 1. The 1 comes down in front, and then it has an exponent of 0, and x to the 0 is 1. So plus 1. And then the derivative of a constant is 0. Okay, so I've taken the derivative. Now they're asking me to set the derivative equal to 0 so I can find the horizontal tangent. So the horizontal tangent means when f prime of x equals 0, right? So I'm going to have 3x squared plus 6x plus 1 equals 0. I actually don't remember having to use the quadratic formula for this problem, but then now I'm wondering if I've ever done 88 before, and if this wasn't a new one that I added on there, because I'm looking at that and I'm thinking, I can't factor that. 3 and 1 to make 3x and 1x to make 3x squared, because my choices of solving that, because it's quadratic, are either factor it or use the quadratic formula, and only 1 times 1, and I'm not going to be able to make 6 that's in the center, so it makes me look back at it and be careful. And so I'm like, oh man, are you serious me? And it's only asking me for the value of x, which I'm grateful, because if it asked me for the value of y, when I have to use the quadratic formula, I'd have to plug that in, and oh gosh, it would be difficult. I'll have to show you. I won't be able to help myself because that's how I am. Okay, so A is 3, B is 6, C is 1. The quadratic formula looks like this: negative b plus or minus the square root. If you don't remember the quadratic formula, do not feel ashamed. My nephew, when he was in Calc 3, I was helping him with his math, and he said, can you remind me what the quadratic formula is? And I said, Calc 3. And I said, yes, honey, I can. and so but this is the quadratic formula. I show my algebra students to put it in there like this. So if you've had trouble with it before, so in here the b's are going, which is 6, and the a's are going, which is 3 right here, and 3 right there, and 1 right there for the c. And then I tell them to simplify it in 3 zones. The zone out here in front, which is just, you don't have to use a calculator for, which is -6. The zone underneath the square root, so I'm putting in what's underneath the square root into the calculator. So that's 6 squared. I tell them to, where you have parentheses, put parentheses. And that's certainly a good way of going. And I'm getting 24 underneath there, and over 6. And then the next thing I'm going to do, so this is what I did with my calculator so far. I did 6 squared minus 4 times 3 times 1. And then what I'm going to do with my calculator is I'm going to do the square root of 24. And so that's the next trick I'm going to do with my calculator. So the square root of 24. You could do the square root of the answer, but it's 2 square roots of 6. So that's equal to 2 square roots of 6. So I'm going to have here x equals -6 plus or minus 2 square roots of 6 over 6. And then there's this triangle that I'm going to draw with the pen that I hope I took the stuff off of. And so, and that triangle goes to those numbers 6, 2, and 6. And what they have in common is 2. So what you do is you divide a 2 out of all of them. So this would be -6 divided by 2 is -3, plus or minus 2 divided by 2 is 1, square root of 6. You just leave the square root alone. Just those 3 numbers that the triangle's touching. 6 divided by 2 is 3. You don't have to write the 1. So of course, when I look in the back of the book, they're not going to have the 1. And they asked for the x value. I'm going to erase the 1 right there, because 1 times square root of 6 is square root of 6. And they just asked for the x value of the horizontal tangents. There's 2 horizontal tangents, and they happen, one of them at the plus here and one of them at the minus. If they had asked me for the y value, if they had asked me for the ordered pair, then what I would have had to do, and fortunately they didn't, they only asked for the x value here. They didn't ask for the ordered pair. But if they had an ordered pair is y, and so you would have to put this in. So what I would do if I wanted to find it is I would put the fraction here, -3 plus, you can only do them one at a time, square root of 6 over 3. And I would hit equals to put that in my answer zone. So I have this now in my answer zone. Then what I would do is I want to put that into my original right here so I can find my y. So that would be my answer cubed plus 3 times the answer squared plus the answer plus 3. So that kept me from having to type that over and over and over again because I put that in my calculator and then hit equals. It's pretty good. It was able to do the exact value and didn't have to give me a decimal approximation, even though that was pretty hard calculation that it had to do. I wouldn't have been, I'm not going to say I wouldn't have been able to do it by hand. I'm going to say I wouldn't have wanted to do it by hand. It would have probably taken an hour, literally. And so with a calculator, though, it's not hard at all. And so if they had asked me, if they asked for an ordered pair, which I know they didn't, but if they did, this is what they asked for. But an ordered pair is a bonus, right? Because I usually ask for an ordered pair. Then the ordered pair would have been -6 plus 2 square roots of 6. Oh, no, it wasn't. It was 3. So I got the non-reduced form. I don't know why I got the non-reduced form. Plus square root of 6 over 3. And then the y value was 36 minus 4 square roots of 6 over 9. Okay. And then there was 2 ordered pairs. The other ordered pair was -3 minus the square root of 6 over 3, comma. and then I can go and find it doing the same story. So I'm going to clear that out. I'm going to put the minus in here. So the fraction minus 3 minus the square root of 6. Downstairs is 3. Hit equals. And then I want to do the answer cubed plus 3 times the answer squared. Oops, I put that all in the numerator, or all in the exponent. I do that sometimes, darn it. So plus 3 times the answer squared, plus the answer plus 3. So if they'd asked me for an ordered pair, I could have done it as 36 plus 4 square roots of 6 over 9. I might have been able to guess that too, but I wasn't in a mood to guess it. So I know that it didn't ask you, this is a bonus, right? It didn't ask you for an ordered pair, it just asked you for the x value on this particular problem. But as a bonus, I found the y value as well at the point where you have the horizontal tangent. So some of the problems ask you just for the x value, and some of them ask you for the ordered pair. I know that they were only asking for the x value, but since I know that I usually ask for the y value, I decided to go ahead and put the y value there as well. And that's the story on this video. Hot diggity dog, one more to make.